So we all know the periodic table increases one by one in atomic number. So if I was reading this from left to right, I could see that every single element just increases by one from the one previous. But the periodic table is actually organized by much more than that. And you can really kind of consider that fact by looking at hydrogen and helium. So why is hydrogen on the left side of the periodic table and the next atom, helium, is over here on the right? Well, it's because we don't just organize these atoms by their number. We also organize them by, for example, their chemical properties. So hydrogen is most similar to these other elements, while helium is most similar to all of these elements. And so that fact can just be summarized down below with that one sentence. Elements in the same group share similar chemical properties. And so if I show just a random group, a group will just be a vertical line. And you can either call them groups or you can call them columns. And now the reason that they're actually going to be reacting similarly is because all of the elements in the same group are going to have the same number of valence electrons. So valence electrons are just the electrons that are in the outermost shell of an atom. So let's say for hydrogen, it only has one electron in its n equals 1 shell. And so it would have a valence electron of 1, or a valence number of 1. Just like that, beryllium is in the second group, and in its largest shell, it has 2 electrons because it's in the second group. Now, jumping the transition metals, we will continue numbering the valence numbers 3, 4, 5, 6, 7, and 8. So boron has 3 electrons in its outermost shell, carbon has 4, nitrogen 5, oxygen 6, fluorine 7, and then helium is the exception, but every element below it is actually 8. Helium is 2. And so one of the principal facts is that all of these elements are going to be trying to get to 8, just because they are actually going to want an octet. The only exceptions, of course, are going to be hydrogen and helium, because the maximum number of electrons they can have in their small shell is 2. But so fluorine in its outermost shell has 7, just like chlorine has 7, just like bromine has 7, all the way down. So just as a fact to memorize, know that the chemical properties of elements are similar in each group, and then also in each group you have a similar number of valence electrons, which are the electrons in the outermost shell. The only other thing we really want to introduce to you are the physical states of the elements at room temperature. So roughly at 25 degrees Celsius, do each of these elements exist as a liquid, solid, or a gas? Now, if you're going to get a question on this on your exam, it's going to be a pretty specific question. But so first, let's just say, what are the gases? So the gases are nitrogen, oxygen, fluorine, going down, chlorine, and then the noble gases. All of these ones down to radon. We're not actually going to talk too much about most of these elements in the bottom row, just because those are actually so large and so unstable, we don't actually know the chemical properties of most of them. Now, moving on, if those are our gases, including hydrogen, of course, hydrogen gas, what are our liquids? Now, our liquids are going to be the most important one for your exam, just because there are only 2 elements that exist as liquids at room temperature. And those are going to be bromine and mercury. And so if I was going to ask you a question, I would just give you 4 random elements and say which one of these is a liquid at room temperature. And one of the answer choices will usually be bromine or it'll be mercury. Now, what does that mean the rest of these are? Everything else, ignoring that bottom row, are going to be solids. And so those are the physical states of the elements at room temperature. And then just to write it down here, liquids, mercury, which is represented by the symbol Hg, and then bromine, represented by the symbol Br.